guys, welcome back to my channel. And today what we will do is we will try to understand the essence of mathematical induction in an easy way with an example of the question: can we cover a checkerboard completely having any one tile removed completely using a triomino? So let's get started. So first of all, I will give you a small introduction to mathematical induction and why do we even use it? Why do we even worry about it? So suppose you have a question or a series of terms or things in front of you, or you are playing a game where some of the special moves they lead to a winning state. Now, you observe the general pattern or a general rule which you think might be always true that leads to the solution of the answer, or no matter how big the question becomes, it always holds true and leads to a winning state of the board, or leads to answer to the problem you are solving. So you want to verify whether what I'm thinking, what I believe, or what I'm thinking is the rule that is true for all input sizes actually is true for all possible cases or not. So that for that, verifying that yes, this rule is the actually true for no matter what case of the question we are dealing with, we use mathematical induction. Okay, so now we will see a small question to understand how mathematical induction helps us verify what we believe is true or our hypothesis. Okay, so the question is, can we cover a 2 cross 2 की power n cross 2 की power n checkerboard with any one tile removed from it? So for example, I can remove this one tile from the checkerboard. These three are the only tiles in the checkerboard now, using a triomino. Now what is a triomino? This is a triomino example. So these any three L-shaped consecutive tiles of the checkerboard is covered by this triomino. So this is a question for any board, any checkerboard of size 2 की power n cross 2 की power n. Okay, so let us see. First we will see the first step of mathematical induction, that is the base case. Okay, let's see the base case. So let's move ahead. Yes. So this is the base case. No, in easy term, what do we mean by a base case? Base case means the smallest size input or smallest size, very trivial question, which you can answer using a pen and paper. And you can see that what you were thinking, that yes, I can cover this checkerboard with one tile removed with a triomino for this smaller 2 cross 2 checkerboard is holds true. Okay, the smallest question for which the general trend or hypothesis is true. That is your base case. Okay, so our base case, the smallest size checkerboard is 2 cross 2. Okay, and we have removed one tile. Okay, now we can see it is very visible that I will change the color to maybe blue. It is very easily visible that I can cover. Yeah, I can cover this board, these three tiles, using this blue color. This blue color represents a triomino. So I can easily cover with a triomino. So for the base case, our assumption or our belief or our hypothesis is true. This is the first step of mathematical induction. Okay. Now we will move on to the next step of mathematical induction. But before going actually to the theoretical next step, I will give you another example how using the smaller previous result that we know is true, we are we are trying to prove finding the solution whether our assumption is true for the bigger question or not. Okay, so we are taking a one bigger size board. We took earlier 2 cross 2 board. Now we will take a bigger size board of 2 की power 2 cross 2 की power. Okay, so that means it is nothing but I want to write this bigger question in terms of the smaller 2 cross 2 board. Can I write it like this? 2 cross 2 this into 4. Pause and think, how did I write this? That means I can break this bigger question of 4 cross 4 board into 4 problems of size 2 cross 2. Why I could do this? Because 2 square can be written as 2 into 2 and 2 square can be written as 2 into 2. So 2 into 2 became 4. So 4 problems of size 2 cross 2. Okay. So I'll change the color maybe to yellow. Okay. So I can this in this 4 cross 4 board, what I do is I remove any of the square. I will remove this corner square for example. This is not there. This square we are removing. Okay, so can we cover this 4 cross 4 board using triominoes? So we broke the question. Okay, so now if I will color the board, divide the board into 4 problems of size 2 cross 2. Okay, so here we have 4 problems of size 2 cross 2. And what we will do, I know from the previous slide, from the previously we saw that use when one tile is removed from a 2 cross 2 checkerboard, I can tile it. So what I will do, I will assume that we don't have this we don't have this corner. I will assume it. If I don't, this is the 2 cross 2 checkerboard. If I don't have this one square, then I can definitely tile it. See, I can tile it with a triomino. This is the triomino. This dark blue color, this is the triomino. I can tile it. Again, for this square, if I assume that this corner tile is not there, okay, we'll just assume it. It is there for the bigger question. But now for this, only this small problem of size 2 cross 2, this small problem of size 2 cross 2 checkerboard with one tile removed, I can cover this using a triomino. Okay. So what we are doing, we are using the smaller checkerboard answer to prove that we can tile the bigger question of size 4 cross 4. Okay, again we will assume that we don't have this corner tile, and then again we are able to cover the remaining board 2 cross 2 board using the checkerboard, using the triomino. And I know this tile is originally in the question is removed, so I can cover this 2 cross 2 checkerboard also with a triomino. Now you see these three. Now can I cover these three x's? Actually in the original problem these are part of the checkerboard, but this is the only remaining part that is not covered with a triomino now. And these three x's, they are in the form of an L-shaped consecutive. So it can be covered using one more triomino. So the answer is yes. A 4 cross 4 a 4 cross 4 checkerboard can be covered using triominoes, and we used the result of a smaller problem of size 2 cross 2 to prove that it is true for 4 cross 4 as well. And this is the intuition of the inductive step. So using the answer, we will assume that we have already proved for a smaller problem board of size 2 ki power k cross 2 ki power k, yes, we can cover with a triomino the whole board with one tile removed, and use that result to prove for a bigger problem of size 2 ki power k plus 1. Okay, I will change the color of size 2 की power k plus 1 into 2 की power k plus 1. Okay, that is the inductive step. And I will break this bigger problem into in terms of the smaller problem of size 2 की power k. I can write it 2 की power k cross 2 की power k. And how many problems of this kind? 4 problems of this kind. Because k plus 1 means 2 की power k into 2 and 2 की power k into 2. So these two and this 2 becomes 4 times the smaller problem of size 2 की power k into 2 की power k. Okay, hope this makes sense to you. It's clear to you. So I will just erase everything from here. Okay. Okay, we will move to the next slide. Now we will go to the actual theoretical inductive step. Now we have in the inductive step, we assume the hypothesis or our assumption that yes, we can tile using triominoes when any one tile is removed from a problem of size 2 ki power k into 2 ki power k checkerboard. Yes, we can cover it. This is, we will assume it to be true and try to prove that we can tile a problem, bigger problem of size 2 ki power k plus 1 into 2 ki power k plus 1. That is, we will break the bigger problem into 4 problems of size 2 ki power k into 2 ki power k. So I will divide this checkerboard into 4 problems, okay, of size 2 ki power k. See, now you will be able to see that these are 4 problems of size 2 ki power k, and originally in the question any one tile from the checkerboard we will remove. Okay, we will remove this tile now. Okay, now how do we do this? Again, similarly we will do the same thing. Okay, we know that if a problem is of size 2 ki power k cross 2 ki power k checkerboard, if one of the tile is removed, then I can cover it completely using the triominoes. So see here, one tile is already removed. So the answer is I can cover this whole checkerboard, small checkerboard of size 2 ki power k into 2 ki power k using triominoes. Now we will assume, that we have removed this tile, okay, and the remaining this checkerboard is also of size 2 ki power k cross 2 ki power k, and we are assuming we have removed this tile, then I can cover this remaining checkerboard using triominoes. Okay, this remaining part I can cover with triominoes because we assume the hypothesis to be true. Okay, now next, the upper similarly we will do it for the upper 2 ki power k cross 2 ki power k smaller checkerboards as well. Similarly, we assume this part is removed, this part is removed, and the remaining checkerboard we can tile it using triominoes. The remaining checkerboard we can tile with triominoes completely. Okay, now only part that has to be covered is this L shape that we assumed are removed, and definitely we can cover this, we can see it, we can cover with one triomino. So the answer is yes. Yes, the any size of checkerboard of size 2 ki power k plus 1 into 2 ki power k plus 1 can be covered using triominos if any one tile is removed from the checkerboard. So for the any input size, no matter what is the size of the checkerboard, we can directly conclude that our assumption or what we were thinking that this rule is true is actually true. Okay, you can conclude it using mathematical induction. So how, I hope you have understood the intuitive meaning of what is mathematical induction. Okay, I will remove everything from screen. Okay, so I hope I will summarize what is mathematical induction. Used to verify our assumption, that is that should be true for any case of our or any input size of our problem or our series, and we use it to verify that yes, this formula or this rule holds true or this property holds true no matter what is the size of our input or what is the term of our input. Okay, and for that we first prove using the base case. Base case is the smallest problem or smallest term for which our assumption is true. We prove it. Then next step is the inductive step. We assume our formula or our assumption or hypothesis is true for a problem of size k, and we use that small solution to the smaller problem to prove that yes, it is actually true for a bigger problem, one bigger problem of size k plus 1, and hence we can conclude for the entire series or entire problem, for all cases our what we were thinking was actually true. So hope you understood the essence of mathematical induction, and if you like the video, please like, share and subscribe to my channel, and please tell your feedback in the comment section below whether I could explain to you in a nice way, whether we could understand uh, mathematical induction or not. Thank you. Bye bye.